Okay, in this podcast or screencast, we're going to learn how to graph the tangent and cotangent functions. And we're going to review what tangent is based on the unit circle. So I've got a unit circle with a radius of 1. The terminal side of angle theta is at point x comma y. That means that if I create a little right triangle in here, that distance right there is x, this distance is y, and remember that the tangent of an angle in a right triangle is the opposite side over the adjacent. So it turns out that it's the ratio of y to x. Alright, so armed with that knowledge, let's go over here to Geometry Sketchpad. And I've got point D moving along the x-axis, and there is the x-coordinate of D measured. I have point E moving around a circle here, and what I've done is I've calculated the ratio of E's y-coordinate to its x-coordinate. Why would I want to do that? Well, remember that the tangent of an angle is y over x. So this ratio right here is actually the value of the tangent of angle E. Well, I don't want to do that, so let me undo that. Okay, anyway, you get the idea. So what we're going to do is plot a point whose x-coordinate matches D and whose y-coordinate is this tangent ratio. In other words, the value of the tangent of the angle formed by the radius AE as it goes around the circle. So I'm going to go to Graph, Plot Points. My x-coordinate is going to match D's x-coordinate, and my y-coordinate is going to be the tangent ratio. I plot it, and there it is. Let's go ahead and trace that point, and let's swing E down to 0 degrees. Let's swing D over to the origin. Let's erase our traces, and hopefully when we hit animate points, we're going to get the graph of the tangent function from 0 to 2 pi. Hey, look at that. The y-coordinates of that red graph are tangent values, and the x-coordinates are the same as the x-coordinate of D. And D is going from 0 to 2 pi radians. Notice that as E gets close to pi over 2, or 90 degrees, the graph goes to infinity. When it gets close to negative 90 degrees, or negative pi over 2, the graph goes to negative infinity. Okay, so that's enough of looking at that. Okay, so I've copied and pasted that graph from Sketchpad, and it looks like we have vertical asymptotes there and there, and those happen to occur at pi over 2, where the x-coordinate is 0, and 3 pi over 2, where the x-coordinate down there is also equal to 0. As a matter of fact, if we kept going around the circle and kept plotting tangent, we would have vertical asymptotes at every odd multiple of pi over 2. Negative pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on and so on. So back in Geometry Sketchpad, let's go ahead and graph the function y equals tangent x. And there it is. It doesn't draw the asymptotes, but you notice where they are. They're coming right down at negative 3 pi over 2, negative pi over 2, positive pi over 2, 3 pi over 2, 5 pi over 2, and so on and so on. Now really, just one cycle of tangent is right there. And so the distance it takes to plot one cycle is the period, and to go from negative pi over 2 to pi over 2 is 1 pi. So the period of tangent is 1 pi. That is different from sine and cosine. The period of sine and cosine is 2 pi. All right, now let's take this graph and see if we can figure out what the graph of cotangent would be. Now, cotangent is the reciprocal of tangent. So that means that wherever tangent is increasing, cotangent will decrease. So if you'll notice, tangent is always increasing as we go from left to right. Also, wherever tangent is equal to 0, the reciprocal of 0 is undefined, or in other words, a vertical asymptote. So the first thing we want to do with cotangent is put down our vertical asymptotes. Everywhere tangent crosses the x-axis, cotangent will have a vertical asymptote. Okay, now everywhere tangent is negative and increasing, cotangent will be negative and decreasing. Everywhere tangent is positive and increasing, cotangent will be positive and decreasing. And if you'll notice, everywhere tangent has a vertical asymptote, cotangent has an x-intercept. Whoa, didn't mean to do that. Well, stop. I guess I'll just draw the cotangent in here. So here we go. Cotangent crosses the x-axis everywhere tangent has a vertical asymptote. All of our rules for transformations apply to tangent. For example, if I wanted to do y equals 2 tangent to x, the period is our regular standard period, 1 pi, divided by the number in front of x, 2, which means that instead of going between negative pi over 2 and positive pi over 2, I'm now going to go between negative pi over 4, half of where it usually is, to positive pi over 4. So I draw my asymptotes. And what does that 2 in front do? It just makes it go up twice as fast. That's not an exact thing, just eyeball it. Okay, let's graph y equals cotangent of x minus pi over 2. Alright, cotangent normally goes from 0 to pi with an x-intercept at pi over 2. But everything's going to be shifted to the right pi over 2 now. So instead of having an asymptote at 0 and pi, I'm now going to have an asymptote at pi over 2 and 3 pi over 2. And remember that cotangent is the reciprocal of tangent, so instead of increasing as tangent does, we will decrease. And that is how you graph tangent and cotangent.